In the previous video, we introduced the equation n to the r and showed you how to use that to calculate the number of permutations for a given beat subdivision. So what we're going to do now is connect the dots and show how you go from a computer representation of all of these different note permutations into something that you can actually read and play like a piece of music. So returning to an example from the previous video, let's say we have 4 permutations of A and B. I made a little bit of a jump and showed how you could convert that mentally to notes on a page, either eighth notes or eighth note rests. But the question is, how do you do that in reality? What's the step you use between these two? Now, I mentioned I created a computer code to go through and generate all of the permutations given a note subdivision using something called for loops. Well, when it's in the computer, we work mainly in numbers. Instead of an eighth note or an eighth note rest, we represent this as ones and zeros, where 1 is a hit and a 0 is a rest. And so the result after running these for loops is you end up with a list of hits and rests per each limb for every pattern. As we mentioned before, there are 4,096 individual patterns that show up, and we store those in a matrix that's 496 lines long. Here you can see an example of what this might look like on a computer code. And if I draw on these blue boxes, you can see more clearly what each pattern is. The first one is a rest on each limb. The second one, you play one note on the second beat of the triplet on your right foot, the kick drum. The third pattern, you're playing the third note of the triplet with your left hand on the snare drum, but all your other limbs are resting. And these go on for 4,093 more rows. So in some ways, I solved the initial problem. I figured out all of the different permutations, and with my knowledge of computer code, I can look at them and I can kind of read them, and I could maybe deduce some knowledge from them. And there's like the big data problem I mentioned. You're looking at a data set, and maybe you can get some interesting bits of knowledge from it, but it doesn't really make sense. It doesn't make sense because it's not organized or presented in a way that I, as a drummer, would relate to. And so we need to take it one more step further and make it a bit more digestible. And we do that with 2 ways. The first way is we can change the style of the presentation. We can change it from ones and zeros to notes on a page. The second thing we can do is work with the order of the presentation. I could just give you 4,096 different patterns, and that would technically be everything you could play on a drum set. But is that going to be the best way for you to learn this? I would much rather be guided through each of those patterns in a way that has some sense of logic, that appeals to how I view music. So let's start with style. Again, the idea is, let's take these ones and zeros as rows on a matrix, and eventually turn them into what you see on the right, a sheet of music. As I was working on this project, I learned about a great piece of software from the Create Digital Music blog called LilyPond. Now, LilyPond, as they describe on their website, is a text-based music notation generator that functions a lot more like computer code than a traditional score editing program. Now, when I'm traditionally working in music software, I lay out my notes graphically on a piano reel, or some software has actual notes on a stave that you can write it. LilyPond is a little bit different. It uses a text-based interface to generate musical notes. So if we take one pattern, like the one shown at the top, we can convert it to LilyPond's language as such. We can pick out the time signature that we want. Here we have triplets. We can show that the first note of the triplet is a rest, an eighth note rest, or R8. The second note we want to hit with a ride symbol. So we say symbol ride, 8 for eighth note. And then of course the last beat, again, is a rest. The cool thing LilyPond does though is it can not only generate the sheet music that you see, but it can also output a MIDI file. And that enables you to play back the composition that you generated. So this could be really cool if you wanted to experiment with algorithmic composition a bit more and generate generate a piece of music from some sort of mathematical principle or something. There's a lot of potential here, and I'm definitely looking forward to exploring that a bit more. So we figured out how to generate a piece of music from this mathematical composition. And so what we're left with is, I now have a visual way to see this data. And that's great. That helps me out tremendously in performing this. And I can share this with other drummers and they can perform it. And it's a common language within this drumming community. But the question now is, now that we can share this information in an easy way, are we sharing the right information? And have we presented it in a way that means something, that follows a logical progression as you learn permutation after permutation? This is really where some of the optimization techniques that I use at my day-to-day job at the Jet Propulsion Laboratory came into play. Let's use the end to the R equation one more time. Let's say that I've got 4,096 eighth note triplet permutations on the drum set that I can play. How many different scores can I create where I use each one of those permutations only once? Well, it would be 4,096 to 4,096. That number is huge. Now there's no way that I can work through 4,096 to the 4,096 arrangements of a given piece of music. That's going to take way too long. Instead, I need to use a search algorithm to go and find what I'll call the perfect score. Now before we get into it though, we have to determine what would be a good score in our mind. And actually, even if there is a perfect score, which there isn't, these are a number of the things I want. Firstly, I want this to be educational. I want to be able to guide a drummer through each of these permutations in a way that's logical. So we'll call it an educational arrangement. It may not be the most interesting musically, but it'll be the one that benefits the drummer most technically. So in order to come up with an educational arrangement of music, if we want to call it that, we need to do a number of things. We need to present these patterns in a logical order. These patterns should increase in complexity as we go through the piece of music, and each pattern should build off of the previous one so that a mental connection can be made as you move through and you learn about each new permutation. Additionally, as I said before, I'm okay with there not being any repetition in this piece of music. It does a number of things. It keeps the time you need to play through this entire thing down, and it allows each permutation to shine equally with all the rest.